we're going to be learning all about rocket science. So let's go right back to the beginning and start where they all began. So what I'm going to be doing today is showing you some demos on how rockets work and asking you guys some questions as well to see just how much you know about rocket science. Let's start with one of those questions. So we'd like to know which country invented the very first types of rockets. Now, you might think it is the United States of America. Perhaps you think it's Russia. It could be China. Or maybe you think it was us right here in the UK. Have a little think. Well, I can tell you, if you said China, then you got it spot on. Well done. Indeed, it was the ancient Chinese that originally invented the very first rockets. Now, admittedly, these weren't space rockets. In actual fact, these were used as weapons. They were like huge tubes of bamboo filled with gunpowder, and they would strap arrows to them and fire them at their enemy line. However, the ancient Chinese also realised that when they started adding chemicals to these, they could actually create coloured flames. And of course, these are now very similar to some things we still use today. You got it, they're pretty much like fireworks. So I thought what we'd do today to honour our Chinese ancestors is create some coloured flames of our own. So to do this, we're going to need a couple of materials. We're going to need some fire, which is going to come out of my gas burner just here, and we're also going to need some chemicals. We're going to be using two today. Our first one contains potassium, which is going to give us a nice, bright, purpley pink flame, whilst our second, looking a little murky, is copper. This should give us a bright green flame. And we've mixed these with a flammable liquid called ethanol, which should help us light it on fire. So we're going to turn the lights out in the room and see how these go. Okay, so now we've turned on the lights, let's get our flame going. And let's add our chemicals. So first up, we're going for our potassium, and we're looking for a lovely pink and purple flame. Next up, let's try our copper, which should give us a bright green flame. So that is where rocketry all began. However, we certainly can't launch to space on a firework today. So when we're thinking about launching real rockets up into space, we have to think about how we're going to get such massive machines up there. And to think about this, we also have to look into a very famous scientist and mathematician. That's this chap just here. Now, some of you may know who this is. He may look familiar. You probably guessed it. Of course, it's Sir Isaac Newton. Now, Sir Isaac Newton was famous for many different reasons. But before we talk about them, I want to know if you know why. So here's my next question to you guys. Which subject do you think Isaac Newton worked on? It could be gravity. You might think he worked on rainbows, perhaps the laws of motion, or even the cat flap. Have a think. Well, let's find out if you got it correct. Sir Isaac Newton worked on all of these. So I'm guessing well done to everyone out there. Yes, indeed. Of course, Isaac Newton most famously worked on gravity. Now, of course, he didn't discover it, but he did help us figure out exactly what it is and how we can use it. He also worked on rainbows. When we pass white light through a glass prism, we see the spectrum of colour, that spectrum of light. It was said that he did this in his home by poking a hole in his wall and sticking a bit of paper to it. It was also said that apparently he worked on cat flaps and invented the very first one. Yes, Isaac Newton had a very annoying cat. But today we are particularly interested in Newton's laws of motion. Now, if you've heard of these before, you may be aware that he has 3 of them. And for rocketry, we're particularly interested in that third law. Now, the third law of motion states that for every action, there is an equal and opposite reaction. Now, this simply means that if you've got a force going one way, you should get one going up in the opposite direction. Rockets are a great example. Our fuel pushes down, our rocket goes up. But to prove this, we're going to do another experiment. Now, this is a great one that you guys can try at home too. And to do this, we need just a couple of items. A small airtight canister. We're going to need some water. And we're also going to need a small fizzing tablet, such as an Alka-Seltzer. Now, we're simply going to add these ingredients into the airtight canister, secure the lid, and turn it upside down. But of course, once these are added together, that tablet is going to start dissolving and bubbling inside. Now, can you think what might happen when this is going on? That's right. Eventually, the pressure will build until the lid has to pop off. Now, when the lid pops off, that water will whoosh out the bottom, and because of that, if Sir Isaac Newton's right, our canister should go flying in the air. Let's give it a try. So before we start, we're going to need to put on some safety glasses. And the first thing we're going to do is pop some water into our canister. About 3/4 of the way up should do the job. We're then going to add in our fizzing tablet. The lid goes securely on the top. We're going to turn that upside down and place it in our beaker. We're then going to step back, watch what happens. And just like that, we get an equal and opposite reaction. Our water went shooting out the bottom, and of course, just like Newton said, our canister went flying up into the air. But of course, our modern-day rockets do not fly off the power of water and Alka-Seltzer tablets. Have a little think for a moment. When we launch a real rocket into space, what do they use? That's right, fire. But of course, to get fire, we need something called combustion. Now, we're going to have a little chat about that, but before we do, I was wondering if you know what gets left behind after combustion has happened. This is my next question. So perhaps you think that after combustion, there may be cheese left behind. You might be thinking it's water. You might be thinking it's lemonade. Or perhaps it's just a big old mess. Well, I can tell you, if you said water, then well done to you. You got it spot on. Quite often, when a rocket launches, we don't think of seeing water. However, all of that smoke that comes bellowing out the bottom, quite a lot of that is in actual fact steam or water that's been evaporated. Water, of course, is H2O. This is the chemical symbol. So to get combustion and to get a real rocket launch, we're going to need a couple of different ingredients. First of all, we're going to need a canister to put these into. Now, our other canister was a little small, so we're upgrading this one to this one right here. We're going to add in our first ingredient, which is something we've already used today, that flammable liquid ethanol. And we're going to add in around 30 mils. Should do the job. We then need our second ingredient, which is oxygen. Now, luckily for us, there is plenty of oxygen in the room right now, including inside my bottle. But we do have a slight problem. Currently, my fuel is a liquid and oxygen is a gas. We're going to need these in the same state. So I'm quite simply going to shake my bottle, and I'm going to keep shaking and mixing until we evaporate that fuel inside. Now, as it evaporates, it turns into a gas or a vapour, which is able to mix with the oxygen in the bottle. This means I'm creating a sort of flammable vapour, something we're going to be able to set on fire. Because of course, our final ingredient is separated. I think we're almost ready for launch. I'm going to place this down ready to go. Stop any of our vapor from escaping. And I'm going to get my lighter set up, ready to light our whoosh bottle. Okay, here we go. Let's see if we can get our whoosh bottle to combust and react. We're going to give this a countdown, guys. From 5, 4, 3, 2, 1. Well, that whoosh bottle was amazing. We really saw the combustion happening and our flames leaping out the top of the bottle. But of course it was quite tricky to see that equal and opposite reaction happening. Now you may have noticed that my little pot of fuel, I left a tiny bit at the bottom. That's because I thought we could do that experiment once more, but with a slightly smaller bottle, allowing us to actually see it move. So this time, we're going to repeat the exact same thing, but with a drinks bottle. So into this drinks bottle goes my final bit of fuel. Once again, I'm going to mix this with the oxygen that's already inside of it. So we're creating that nice flammable vapor that eventually our flame will set on fire. Now for this to work, for us to see an equal and opposite reaction, I'm going to try and get this to shoot all the way across my table. So for that, I'm going to need a track. So we're going to lay this in front, we're going to place our bottle at this end, and we're going to light it from this side. Now have a think, if we light it here, which way do you think the flames will go? Where do you think our bottle will end up? Of course, our flames will shoot out this way, and our rocket should whiz off to the other side. But there's only one way to find out. Let's give it a go. So we have our lighter. Again, we're going to give this a countdown from 5, and we're going to see if we can get both combustion and our equal and opposite reaction. Here goes. In 5, 4, 3, 2, 1. And there we go. How cool was that? That bottle went whizzing off with a huge amount of power and speed. And that was from just a tiny amount of fuel inside. Imagine just how powerful a real rocket is when it's launching into space. So we've done loads of cool experiments seeing how rockets work and how we can get them to space. I think it's time to put all of that together and do one final experiment, launching a rocket using something a bit more like real rocket fuel. So to our makeshift rocket today, we are going to be adding oxygen and hydrogen, just like they do in real rocketry. So to launch a real rocket, they need lots and lots of power. So they use liquid oxygen and liquid hydrogen. Now these, of course, put together along with heat, are very dangerous. So whilst I can't play with that today, what I can use is hydrogen and oxygen as a gas. Now, as we said before, there is already lots of oxygen around me, but I'm also going to need to add in hydrogen. So here is some I collected earlier. We are going to fill up my rocket with hydrogen. We're going to set fire to the top, and then we're going to wait for those 3 ingredients to get to that crucial point where we get combustion. Now I'm going to warn you folks, at that point, this will be pretty loud. When it combusts, we should get a big force going down, and our rocket should shoot up into the air. We're combining those flames, that equal and opposite reaction, and combustion to make one final rocket. Let's give it a try. So first of all, I'm going to add in my hydrogen. I'm simply going to do this by placing the tube into the bottom of my rocket just here. I'm then going to release that hydrogen in, filling up the rocket and purging it of any air that's already inside. sounds good to me. So, our next step is to light the top of this rocket, and remember, this could be loud. So hopefully you've enjoyed learning lots about rockets today and realised that actually rocket science isn't that difficult. Thanks for watching and subscribe for more videos like this.